Okay, so now we're talking about chemical reactions with our test prep. So if we look at the equation given, it asks us what is the coefficient. So remember, coefficients are going to be those front numbers. So 1, 6, 2, and 6 for the first product. So we have to keep in mind that we have our reactants on this side, and we're going to have our products here with our yields right in the middle, aka pointing from our reactants to our products. So if we're looking at this one, we would see that our first product is right here, and then our coefficient is the front number of 2. Now our next one says, what is the state of matter? So our states of matter are going to be those symbols at the end, like S for solid, G for gas, L for liquid, and AQ is aqueous, meaning dissolved in water. So if we're looking for our second product, we would now see that it is G for gas. Okay, our next one says HNO3 is classified as a reactant or a product. So we're going to find HNO3 on the left side. So it's going to be classified as, yes, a reactant. Now it's in its second position, but still on the left side of the arrow. And that makes the difference between a reactant and product. Now our final one is going to ask what type it is. So that's like synthesis, decomp, single, double, or combustion. So if we label it, our B is our A, BR is my B, H is my C, and NO3 is my D. So I actually have two couples, which is a big hint now that we got to D. So now A is with D, and we see that C is with B. So yes, this is a double replacement. We have both of our couples switching places. Okay, our next ones are going to be balancing. So when we balance these, we want to find our yields, draw our arrow down, and then make a list of what we have on both sides. Now, the whole goal of balancing is to add those coefficients at the top, aka those lines in front of the compound, to make them equal between our reactants and products. So on our reactant side, we have 1 and 2, 1 and 3. Now we're never going to make a 1 look like a 2 or a 2 look like a 3, so a common factor is going to be 6. Awesome. So when I put a 3 here, it changes BR to 6. When I put a 2 here, it not only multiplies into BR to make it 6, but it changes AL to 2. So whereas our BRs are balanced, we're going to have to go back and put a 2 for this aluminum. And now we are equal between our sides. Now the type. We have two reactants becoming one product. So we would see that this is a synthesis reaction. So we have our A plus our B yields our AB. Okay, our next one, we have C3H8 plus O2 yields CO2 and water. So we have C, H, and O. We have C, H, and O. We'll see we have 3, we have 8, and 2. We have 1, we have 2, we have 2 plus 1 here. Gives us 3. So always start with your C first and then go to your H, saving your O's for the end. So we're going to put a 3 here. Now it not only changes this carbon to 3, but it's going to change this O to 6. Awesome. So now our next one, we're going to see we have a 2 and an 8. So we can multiply by 4. So 4 times 2 gives us the 8 that we need for our H. And then we're going to see 4 times 1 is 4. So 6 plus 10, 6 plus 4 gives us 10. So what can we multiply 2 on this side to get to 10? You've guessed it, it is a 5. So we are all balanced with a 1, 5, 3, 4. And we're actually going to see that this is a special type. We always have the same two products for this type, and I hope you knew that it was a combustion reaction. And we're going to see that it has that hydrocarbon, has the fuel, and then CO2 and water as its products. Okay, now we're using our metal activity series. So we have Fe replacing potassium. So we find potassium, we find Fe, and then whatever comes first. Can Fe go up and replace potassium? That is a big no. Okay, our next one, we have aluminum replacing silver. So find aluminum, find silver. Can aluminum go down and replace silver? That is a yes. So then our next ones, we're going to see if it replaces and then what their products were. So can Mg replace Fe? So we find Mg, we find Fe. Can it go down? Yes. So Mg's new partner would be O, and we would have Fe by itself. Okay, now we have Ag and K. So K is by itself, so can K replace Ag? We see K is here, we see Ag here. Can K go down? That's a yes. So now we're going to have KCl plus Ag. For these single replacements, we see one single element replacing another. Now, let's take a look at our solubility chart, and this is our last part of the day. It's asking us if we have magnesium and nitrate, which is NO3. So we find magnesium here, we find nitrate here, we pull it over, we see that it's going to be aqueous, meaning dissolved in water. Then we look at our next one. We actually have calcium and Br. So we find calcium, we find Br, and we see that this one is also aqueous. Now remember that our solubility table, we have to have a solid, also known as our fancy name of a precipitate, for a reaction to occur. So let's take a look at our last one. We have K2S, which is aqueous, plus Mgi2 aqueous, yields Ki aqueous, and what? So because this is a double replacement, notice how K's new partner is I, so that means Mg's new partner is S. Awesome. I'm glad you saw that switch for this double replacement. So then we find Mg, we find S, and we see it is a solid. So would this reaction occur? Yes, it would, because one of the products is a solid. So thanks for watching as we went through the chemical reactions review for your test prep.